If there is one feature that immediately separates a Python beginner from a professional, it is the mastery of comprehensions and generators. These aren't just syntactic sugar. They are the key to writing code that is concise, readable, and, most importantly, memory efficient. But there is a trap. Misusing them can lead to hard-to-read code and silent memory leaks. Today, we are going from the basics of idiomatic one-liners all the way to the black magic of coroutines and generator pipelines. Before we start optimizing your code, if you want to optimize your career, join our Discord server. We have a channel dedicated to code reviews where you can post your comprehensions and get feedback from senior devs. It's the fastest way to learn. Link is in the description. Let's start with Phase 1. Foundations. The standard list comprehension syntax follows a specific grammar, expression for item in iterable. It creates a new list by applying an expression to each item in an existing iterable. But the real power comes when we add conditional filtering. By placing an if statement at the end, we filter items before the expression runs. Now, swap those square brackets for parentheses. You haven't just changed the shape, you've changed the underlying object type. This is a generator expression. A list comprehension builds the entire list in memory immediately. This is eager evaluation. A generator expression is lazy. It yields one item at a time and waits for you to ask for the next one. Let's look at code. You aren't limited to lists. You can use curly braces to create set comprehensions, which automatically remove duplicates, or dictionary comprehensions using the key value syntax. A common point of confusion is the ternary operator. If you want to filter items out, the if goes at the end. But if you want to keep the item but change its value based on a condition, like replacing none with 0, you use the if-else structure before the for keyword. Let's move to Phase 2, intermediate patterns. What happens when you need to flatten a list of lists? The syntax for nested loops and comprehensions often confuses people. The rule is, read it exactly like you would write nested for loops in standard code. For row and matrix comes first, followed by for item in row. The visual order matches the logical nesting order. Now let's push harder on Phase 2. Beyond simple flattening, we can use nested comprehensions for matrix operations. For example, transposing a matrix, swapping rows and columns, can be done by nesting the iteration logic itself. Row I for row in matrix for I in range. Also, a crucial distinction in Python 3, scope isolation. Variables defined inside a comprehension do not leak into the surrounding scope. This was a major bug source in Python 2, but now your iteration variables are safe. Moving to Phase 3, advanced generator mechanics. We know generator expressions, but we need to talk about the yield statement. When a function uses yield, it doesn't return a value and exit. It pauses execution and saves the stack frame. This allows for infinite generators. You can write a while true loop that yields values forever. And as long as you consume it safely, perhaps using itertools.islice, it won't crash your memory. This leads to generator pipelines. This is the Unix pipe philosophy applied to Python. You can create a generator that reads a file, pass that generator to a filter generator, and pass that to a transform generator. Data flows through the pipeline one item at a time. You can process a 100 gigabyte file on a machine with 8 gigabytes of RAM because you never load the whole file at once. Sometimes you need to delegate part of your generation to another subgenerator. Instead of looping over the subgenerator and yielding each item, use yield from. This is syntactic sugar for delegation, and it handles the tricky parts of signal propagation automatically. Simplify your Python generators with yield from. It offers cleaner code and automatically handles signal propagation, making delegation to sub-generators seamless. Enjoy better error handling and even capture return values effortlessly. It's the elegant solution for efficient generator chaining. Now for phase 4, the tricky techniques. Python 3.8 introduced the Walrus operator. In a comprehension, this allows you to calculate a value, check a condition, and use that value all in one pass. Without the Walrus, you'd have to call slowcalc twice, once to check the condition and once to store the result. Y for x in data if y equals slowcalc x is greater than 0. This creates massive performance gains. Here's a pattern few know. Iter, callable, Sentinel. You can create a generator that calls a function repeatedly until it hits a specific stop value. This is perfect for reading binary chunks from a socket until empty. And finally, bidirectional generators, coroutines. A generator isn't just a producer, it can be a consumer. By using received equals yield output, you can use the .send method to inject data back into the generator while it's running. This transforms your generator into a lightweight thread or state machine. Let's build a real-world tool, a lazy log analyzer. We will simulate a massive server log. The generate dummy logs function generates a large dummy log file for testing. The log pipeline function is the pipeline coordinator, connects the generator stages together. We will use iter f.readline to read it lazily. We will use a generator expression with the Walrus operator to parse regex patterns only once per line. Finally, we will pipeline this into a counter that aggregates errors, all while keeping memory usage near 0. Phase 5, warning signs. Just because you can do it in one line doesn't mean you should. Never use a list comprehension just for side effects like print X for X in items. This builds a list of none values just to throw it away. Use a standard loop. Also, be careful with random filters. If you filter on random and then select random, you are calling the function twice. The value you checked is not the value you kept. I've uploaded the code for the log analyzer pipeline and a cheat sheet of these advanced patterns to the GitHub repo linked below. There is also an auto-grading quiz on our Discord to test if you really understand yield from VS Yield. To summarize, use comprehensions for simple transformations, generators for large data streams, and coroutines for stateful pipelines. If you enjoyed this Python masterclass, don't forget to like this video, subscribe to the channel, and comment below what you want to learn next. Our next lesson is Object-Oriented Programming Classes and Objects.